In this video we will explain about learning curve. The learning curve concept illustrates how performance improves with experience. This presentation explores insights from F. Robert Jacobs and Richard B. Chase on how this principle applies to various fields, enhancing our understanding of efficiency and productivity. The learning curve is defined by its slope, which indicates the rate of improvement. A steeper slope signifies faster learning, while a shallower slope indicates slower progress. Understanding these concepts helps organizations optimize their training and development strategies. Jacobs and Chase emphasize the importance of the learning curve in business operations. Companies can apply this model to reduce costs, enhance productivity, and improve quality by analyzing how skills develop over time and adjusting their strategies accordingly. While the learning curve provides valuable insights, there are challenges. Factors such as variability in individual performance and external influences can distort the expected outcomes. Jacobs and Chase highlight the need for careful analysis to ensure accurate application. Understanding the learning curve is crucial for organizational success. Insights from Jacobs and Chase reveal that by embracing this concept, businesses can foster continuous improvement and effectively navigate challenges in learning and development.
In this section, let's discuss how a company's location affects its impact and reporting. Different places have unique environmental and social needs, and companies must align their practices to fit these needs. This includes localized social impact. Companies report on CSR programs tailored to local needs, showing how they contribute to local communities. Natural resource management. In areas with limited resources, companies focus on sustainable practices like water conservation. Strategic benefits of location-based reporting include regulatory compliance, improved stakeholder trust, and long-term value creation. Now let's define distribution. It's the process of moving products from production to customers, focusing on efficiency. Governance and distribution ensures these practices are ethical and align with company values. Let's talk about the importance of strategic governance fit. Manufacturers benefit when their governance approach matches the distributor's focus, which usually falls into two types. Economic role distributors focus on profit and respond well to incentive-based governance. Normative role distributors value relationships and perform best with trust-based governance. Distributor relationships and market uncertainty. Relationship stages also affect governance. In the build-up stage, new partnerships, either governance approach can work. In the mature stage, established relationships, governance must align with the distributor's role to maintain trust and performance. In uncertain markets, distributors need governance that aligns with their role to help manage risks. But in stable markets, this alignment is less crucial. Next, let's talk about logistics, a key part of the supply chain that ensures goods reach customers efficiently. Logistics involves managing the movement of materials and products, often with the help of third-party providers like FedEx or DHL. Transportation modes are essential in logistics. Trucks for flexibility, ships for low-cost bulk movement, air for speed, trains for economy, pipelines for specialized transport, and hand delivery for final delivery to customers. Warehouse design. Warehouses play a critical role in managing inventory flow. Two key strategies here includes cross-docking, which moves products directly from incoming to outgoing transport to reduce costs, and hub and spoke, which optimizes regional distribution. Finally, location of logistics facilities impacts delivery speed and costs. Companies choose locations near customers and infrastructure to reduce lead times and improve efficiency.
Companies like Toyota, Ford, and Tesla have used learning curves to reduce production costs and improve efficiency. Aerospace and defense. Companies such as Boeing, Lockheed Martin, and General Electric have applied learning curves to improve complex manufacturing processes. Electronics and semiconductors. Intel and Apple have leveraged learning curves to improve production processes for electronics and chips, heavy equipment, and appliances. Companies like Caterpillar and Whirlpool use learning curves to streamline production in heavy machinery and home appliances. Results of TPS implementation: enhanced production efficiency, quality improvement, cost reduction and waste minimization, employee involvement and continuous improvement. Enhanced production efficiency. TPS helped Toyota streamline workflows, reduce inventory through just-in-time (JIT) manufacturing, and minimize lead times, which allowed TMMK to become one of the most efficient automotive plants in the U.S. With JIT, components are delivered as needed, reducing excess stock and lowering storage costs. Quality improvements. TPS also emphasizes Jidoka, automation with a human touch, enabling employees to halt production if they notice defects. This approach helps to maintain high quality and prevents the propagation of issues along the production line. As a result, the Kentucky plant has maintained high standards, contributing to Toyota's reputation for vehicle reliability. Cost reduction and waste minimization. The TPS principles of reducing waste, muda, and optimizing processes allowed Toyota to achieve lower production costs. By focusing on efficiency and eliminating unnecessary steps in production, Toyota was able to keep costs down while maintaining high production volumes. Employee involvement and continuous improvement. TPS encourages worker participation in continuous improvement, which is central to the Kaizen philosophy. Employees are empowered to suggest process enhancements, creating a culture of ongoing efficiency gains. Overall, the implementation of TPS in Toyota's Kentucky plant has led to over 11 million vehicles produced at TMMK to date, including popular models like the Camry, and has solidified Toyota's status as a leader in U.S. automotive manufacturing. These achievements have also strengthened Toyota's commitment to U.S. production, evident in its continued investment in the plant, including recent advancements in hybrid and electric vehicle production. DHL Supply Chain is a prominent division of the DHL Group, recognized as the world's leading logistics provider. Here's a detailed overview of their supply chain operations. Global presence and market leadership. DHL Supply Chain operates in more than 50 countries and holds a significant market share of 6% in the global contract logistics market as of 2022. This makes them a leader in the fragmented market of contract logistics. Comprehensive services. The company offers a wide range of services that include management and value-added services tailored to meet the specific needs of their clients. These services are designed to maximize the value of supply chains by providing reliable logistics support worldwide. Technology and innovation. DHL Supply Chain is at the forefront of technology logistics, offering expertise in areas such as end-user devices, value chain services, and infrastructure equipment. This technological expertise helps them to efficiently manage complex supply chain operations. Corporate structure. As a division of Deutsche Post DHL, DHL Supply Chain is headquartered in Bonn, Germany. The parent company, Deutsche Post, employs approximately 510,000 people globally, underscoring the scale and reach of their operations. DHL Supply Chain's extensive network and innovative solutions make it a key player in the logistics industry, providing customized and efficient supply chain solutions to businesses around the world. The Boeing 747 Dreamlifter is a critical element of Boeing's 787 production model, enabling the efficient transportation of large, pre-assembled parts from a global network of suppliers. By reducing transport times, improving just-in-time delivery, and supporting modular assembly, the Dreamlifter system has significantly enhanced Boeing's production capability, efficiency, and flexibility in meeting airline demands for the Dreamliner. The Dreamlifter is a key part of the aerospace supply chain, transporting large aircraft parts, such as wings, from international locations. It can transport up to 3 times the volume of cargo than a traditional 747-100F jet. Slide 8. 1. Purpose and design of the Dreamlifter. Oversized cargo transport. The Dreamlifter's main purpose is to transport large, pre-assembled sections of the Boeing 787, such as fuselage sections, wings, and tail assemblies, from various suppliers worldwide to Boeing's final assembly plants in Everett, Washington, and North Charleston, South Carolina. Modified structure. Boeing transformed the 747-400's fuselage into an elongated cargo space that can carry oversized parts. The Dreamlifter is 65,000 cubic feet in cargo volume, over twice the capacity of a standard 747 freighter. Swing tail mechanism. The Dreamlifter has a distinctive swing tail that can open, allowing large components to be loaded directly into the rear of the aircraft. This feature simplifies loading and unloading procedures, making it easier to handle large, one-piece components. 2. Global supply chain coordination. Component suppliers. Boeing relies on a global network of suppliers to produce major 787 components. For example, fuselage sections are made in Japan by Kawasaki and Mitsubishi, wings by Mitsubishi Heavy Industries, and other parts in Italy, South Korea, and the United States. Transport efficiency. The Dreamlifter allows Boeing to use a just-in-time delivery model, coordinating with suppliers to ensure that large parts are delivered exactly when needed. This minimizes inventory and reduces storage requirements at the final assembly plant. 3. Loading and unloading process. Specialized equipment. Loading and unloading the Dreamlifter requires specialized equipment due to the aircraft's large swing tail and the size of the parts it carries. Boeing developed the custom cradle system to secure oversized parts during flight. Swing tail operation. The rear fuselage swings open, allowing ground crews to load and unload parts through the back. This design eliminates the need for specialized airport infrastructure, which would be required for side-loading or top-loading methods. Dedicated loading teams. Boeing employs specialized loading crews trained to handle the unique challenges of transporting oversized cargo in the Dreamlifter. They use custom-designed rigs, dollies, and lifts to secure and transport parts within the aircraft. 4. Flight operations and scheduling. High utilization. The Dreamlifter fleet consists of 4 aircraft, which are scheduled to maximize efficiency, with frequent flights between key supplier locations and Boeing's final assembly plants. The high utilization rate of each aircraft helps reduce downtime and maximizes the capacity of the global supply chain. Dedicated routes. Dreamlifters operate on fixed routes between supplier hubs and Boeing assembly plants, with flights frequently traveling between Asia, Europe, and North America. This ensures timely delivery and minimizes potential delays. Quick turnarounds. The streamlined loading and unloading process enables quick turnarounds, often within hours, allowing Dreamlifters to make multiple flights within a week to keep up with the 787 production pace. 5. Coordination with final assembly lines. Just-in-time, JIT, production. The Dreamlifter system is integral to Boeing's JIT manufacturing for the 787. It delivers components precisely when they are needed in the assembly line, reducing inventory costs and ensuring a continuous workflow. Pre-assembled components. Since each 787 section arrives at the assembly plant mostly pre-assembled, Dreamlifter deliveries support the modular production model. Once the components arrive, they can be directly integrated into the final assembly line, minimizing assembly time. Continuous communication. Boeing maintains continuous communication with suppliers, pilots, and ground crews to ensure parts are delivered on schedule, with adjustments made in real time for delays, weather, or other disruptions. 6. Enhanced efficiency and cost savings. Reduced transit times. Previously, Boeing used sea and land transport for oversized components, which could take weeks. The Dreamlifter system reduced transit times from weeks to days, significantly speeding up the production process and minimizing delays. Lower inventory needs. Faster, reliable delivery via the Dreamlifter means Boeing doesn't need to stockpile large parts on site. This reduces warehouse space, inventory costs, and on-site labor for inventory management. Improved production scalability. The Dreamlifter allows Boeing to increase or decrease production rates by adjusting the frequency and timing of flights, providing flexibility to respond to demand without major adjustments to infrastructure. 7. Continuous improvement and safety measures. Maintenance and upgrades. Each Dreamlifter undergoes routine maintenance and periodic upgrades to ensure reliability. Boeing also makes adjustments to loading systems and equipment as necessary to improve efficiency and handle any design changes in 787 components. Safety protocols. Since the Dreamlifter carries large and heavy cargo, Boeing enforces strict safety protocols for loading and unloading, in-flight securing, and handling of parts. Specialized training for pilots and ground crew is also essential to manage the risks associated with transporting oversized loads. The Boeing 747 Dreamlifter is a critical element of Boeing's 787 production model, enabling the efficient transportation of large, pre-assembled parts from a global network of suppliers. By reducing transport times, improving just-in-time delivery, and supporting modular assembly, the Dreamlifter system has significantly enhanced Boeing's production capability, efficiency, and flexibility in meeting airline demands for the Dreamliner. The Dreamlifter is a key part of the aerospace supply chain, transporting large aircraft parts, such as wings, from international locations. It can transport up to 3 times the volume of cargo than a traditional 747-100F jet,